This is section 9.5. Will be graphene hyperbolas. The set of all points P such that the difference of the distances between P and two fixed points called the foci is a constant. Looking at the picture here, different than an ellipse where we're looking for the sum of 2 points, and that would be a circular type figure. This is the difference from the 2 points, and we have a constant. So the farther you go out minus the farther you come back, you're going to have a constant value. The transverse axis passes through the two foci. It's called a transverse axis rather than a major axis. They would mean similarly the same. The midpoint of the transverse axis is the center of the hyperbola. The hyperbola has two branches and has two asymptotes. If we look here in the picture, we can see a center. We have a transverse axis in between our two vertices. Notice how the hyperbola curves. This branch curves, so the focus point is inside the curve. It's farther away than A is from the center. That's what makes it different than an ellipse. How does this curved shape open up? It opens up at the slope of B over A. A is the distance to the vertex always. This is your B value. This would be your A value. Notice here in a hyperbola that the A value and the B value are not always one's bigger than the other. And in an ellipse, the A is always bigger. But in an hyperbola, it's possible that A would be smaller, like it is here in this picture. We have two equations, similarly as we did for ellipses. One's going to start with x squared and have y squared, still equal to 1. Still has our fraction with our a and the b, our a squared and b squared. A squared and b squared will always be in that order. And we put a minus in between. It's the difference. X squared minus y squared. Both of them divided by their a's and b's squares. The transverse axis is horizontal. In this case, it would be y equals 0. We have our asymptotes. When we look at the asymptote, we see the distance to the vertex, remember, is a. So if you're going from a point to a point along your asymptote, this would be your b length. So you're up b and you're over a. Come in the other direction, you'd be down b and over a. So it's plus or minus b over a. And in terms of an asymptote, that has to have an x value with it. The vertices are a distance of a away. And if it's horizontal, then of course the a would be on the x. If the hyperbola opens upwards or downwards, it follows the y-axis. Then when we come over to the equation, it's going to be y squared followed by an x squared equals 1. The y squared comes first, and when you're subtracting, that does make a dramatic difference. In an ellipse, you might have y squared plus x squared. There's no difference if you say x squared plus y squared. But here in the hyperbola, because it's subtraction, it does make a difference. The a value still comes first, a squared, b squared. The a is following the y, so you know it's opening up or down, or up and down for a hyperbola. So we have a vertical transverse axis, which would be x equals 0. And by looking here at the slopes, if the distance to A, or to the vertex, is a value of A, then it's up is A and over is B. Up is A and over is B. Rise over run, A over B. The vertices are up and down. Looking at your picture, 0 for your x's, A for your y coordinate. The foci lie on the transverse axis, and their relationship is a squared plus b squared equals c squared. If you remember the ellipse was a squared minus b squared. The equation has a plus for an ellipse, but here for a hyperbola, the equation has a minus, and to calculate where the focus is located, the c value, you would add them. If you look at the picture, you see that the focus is farther than A, it's bigger than A, and that might show you or make you understand why you have to add or make A even bigger to get out to C. So let's try to graph what we have here. We first need to put this in standard form. So we're going to divide by 36. So 4 goes into 36 9 times. So you have x squared over 9. You have y squared over 4 equals 1. You notice that this is an ellipse because you have two variables that are squared, and it's it's not an ellipse, it's a hyperbola. You know that this is a hyperbola because you have two variables that are squared with a minus sign in between. We notice that the a value, which is always first, a squared equals 9, so the a equals 3. The b squared equals 4, so the b equals 2. So we're going to come to start to graph this. Because there's no parentheses with our x and the y, we have a center point at the origin. All of these hyperbolas will have a center point at the origin. Our a value is following the x, and we go 3 out, 3 back. The b value is 2. So this is our vertex. Now with these points, we're not going to make any ellipse type shape out of it. You could come around and make a box. That can help you understand what the asymptotes are. So if you come through with a straight edge, you can connect those 2 points together, and you're going to see that this has the slope of your b over a, b over a. And then we don't have to plot any points. We can just curve this around so that they follow the asymptotes. We like to write our equation, x squared over 9 minus y squared over 4 equals 1. Your vertices, they're 3 over and 0 up. So they're plus or minus 3 comma 0. You don't have co-vertices for this. You still have a B value, but you don't have co-vertices. You just have vertices and foci. So to calculate your foci, we need to know what the C value is. A squared plus B squared equals C squared. The A is 9. The B is 4. So we get 13 equals C squared. So the square root of 13 equals C. And that's approximately 3.6. So if that's 3.6, then we're going to come out 123.6 and 123.6. Now we can label those as plus or minus 3.6 comma 0. The next graph, notice how you have a y squared and an x squared. They're not in the xy order. And there's a minus, so their order is okay. It's a hyperbola because there's a minus between them. But we don't equal 1, so we have to divide by 16. So we're going to get y squared over 16 minus x squared, you could say over 1, equals 1. So your a squared always comes first. It doesn't have to be the largest. Your b squared is a value of 1, and when you take the square root of that, you still get 1. So when we come down to graph that, we have our center. Our a value is going to follow the y coordinate. So that's a value of 4 away and 4 down. The b value is 1. We don't necessarily, those aren't considered co-vertices, but we can use that number to help you put a box in here. Which then helps you line up where to put your asymptote from vertex to vertex. Remember that you have y squared. That's your first term. So you know that your branches will open up and open down. Now to calculate where your foci are at, you have a squared plus b squared equals c squared. Your a value squared was 16. Your b value squared was 1. So you have 17 equals c squared. You get the square root of 17, which is just a little bit more than 4. So on your graph, that's just a little bit more than 4. And we like to write the equation. Y squared over 16 minus x squared, you could say over 1 if you wish, equals 1.